Okay, now we're going on to Chapter 11 review as part of our sensors course. In the Chapter 11 review, we dive into electrical pressure instruments. Now, these instruments are all converting some sort of mechanical pressure sensor into an electrical signal that can be used by your PLC, by your automation. And this is where the rubber meets the road for the sensors class in terms of pressure. The other instruments are very useful. You find they're useful as a mechatronics student, but these sensors right here are going to be the only ones that you want to wire into your PLCs. And so at the very beginning of this, it talks about the definitions of an electrical transducer, which you should know already. It's just converting input energy, such as mechanical or pressure, into output electrical energy, which is some sort of signal. And our two most common signals from sensors are 4 to 20 milliamps and 0 to 10 volts. However, more and more, we're developing sensors that have their own communications. So the sensor will send a communication signal over a wire of some sort, maybe even over the internet on a Cat5. And that's becoming more and more common. But the two most common sensor signals right now are 4 to 20 milliamps and 0 to 10 volts. So the transmitter is the device that converts the low-level signal from the pressure sensor into the signal that will go to your PLC. We also have a term of a pressure switch, which is a very simple device, not always an electronic device, but the pressure switch is designed to have a discrete or on-off signal, so it goes on when you hit a certain pressure point. So let's talk about the different methods that they're going to use to measure pressure. One way they do that is they have these strain gauges. Strain gauges are used a lot in different engineering applications. In the pressure world, because we're measuring how, say, a diaphragm bulges, the strain gauge is perfect. The way a strain gauge works is when I flex that substrate, it's usually a flexible, like a plastic, it's printed on there. When I flex that plastic, this resistor, which is inside that plastic, changes its resistance so that I can use what's called a circuit bridge and measure the resistance change compared to other resistors. In other words, I have 1, 2, 3 set resistors, and then my strain gauge is my fourth resistor. So my voltage will vary slightly as that resistor changes. So my V0 will change slightly, and I can use that voltage measurement as a methodology to determine how much I've flexed this strain gauge. So it's a great way to see if something's bent. So I can attach it to a metal rod, bend the metal rod, see that resistance change, therefore the output voltage change. Or if I can attach it to a diaphragm, like a substrate, to a strain gauge or pressure gauge, and then when that pressure gauge bulges slightly, this bends, and therefore its resistance changes, and therefore I can get a reading on my sensor. So you guys don't need to know all the details, practically speaking, in a mechatronics day-to-day standpoint, but learning these terms is very useful. Very, very useful, especially if you want to go on to your four-year engineering degree, learning about how this bridge circuit works, which is this thing right here, and is very, very important. And you can learn about how temperature compensation works with that circuit. So it talks about a dummy gauge that you would basically have two resistors in opposite directions to automatically cancel out any temperature changes that might change the resistance of your circuit. So you're only measuring strain based on the actual bend of the gauge rather than just the temperature change. So that's an important thing because resistance does change based on temperature slightly. Another way of measuring pressure changes is by capacitance. So we have capacitance transducer, which is a slightly different way of measuring the pressure. And basically, we can increase and decrease the capacity of these special cells. So by creating two wires and a substrate in between with a center diaphragm, if that diaphragm expands and contracts, it will change the capacitance, and this becomes a slightly more accurate and much more expensive strain gauge. So that's another electrical thing we can use. I have never used one of these guys. They're unusual. Inductance is another key factor that I can use. In this case, I would have to use it with a bellows type operation where I would use a coil, and the further that coil expands, it pushes a rod on a piece of metal, and the more that piece of metal goes into the coil, then that inductance changes. And therefore, as that inductance changes, I can use that in an electronic circuit to determine what the pressure change was. I've actually never used one of these either. They're kind of obsolete. Strain gauges are the most common ones in my experience. Reluctance is another characteristics we can use. I'm not going to go through that. It's not very common. Read about it. The last one I'm going to talk about, I think that's the last one, is probably the up and coming most common pressure and weight sensor, which is piezoelectric. Now, these are really cool. These are little crystals. They're solid state. And the more you squish this crystal, the more electricity squirts out of it. And it's used in weigh scales. So I can put one of these crystals underneath a weight. I squish down on the crystal, and then I set up some basically contacts, one on the top, one on the bottom, and I can measure a voltage being squished out of that crystal. It's actual voltage output on the crystal, which is a really cool kind of high-tech way of doing it. No moving parts, and that they're very durable, they're hard to break, and they're not super accurate, but they do a pretty good job. So I can use this crystal for weight measurement. I can use this crystal for measuring pressure. So I just have a diaphragm go up against it, and as that diaphragm has pressure on it, then that crystal gets pressure on it, and that gets converted to electricity. All right. And so I guess this is the reluctance one. Over here is the one I think is really cool, which is the piezoelectric pressure transducer on page 120. Very, very simple. And that crystal right there at the bottom is the most important aspect of that measuring system.